Hi, students, and welcome to our lesson on linear equation word problems. And now we're really getting into the part of algebra where you can see firsthand how useful algebra is for everyday problems. We've got some great real world problems, and I challenge you to use algebra in your own usefulness, for your own utility in some way, shape, or form. And the alternative assessment we talked about for the test coming up is a great opportunity to do that. Before we start, we're going to work on our do now, which is a prompt about a life plan quote that we're going to read. And our objective will be to learn how to solve two types of linear equation word problems. Now, there are two more types that we'll do Monday, but for now, we're going to solve what we call slope intercept and standard form type word problems. So our essential questions ask, how can I solve a linear equation word problem when I am given a rate of change and a starting point? So that's what you'll look for in problems. Highly tested area. This part of algebra, this is what your PSAT or SAT, your high school admissions folks, they want to know if you understand this part of algebra. Algebra really is about linear equations and slope, and a lot of it. We'll get to quadratics at the end of the year, but really you need to master this stuff in the middle. So really work hard, okay? I know you will. The second type of problem, how can I solve a linear equation word problem that relates two different objects, okay? And what we're going to end up with is two different sets of points with those kinds of problems. So we're going to watch today's video and complete 4 type 1 problems. That's this part here. And we're going to complete 4 type 2 problems. Those are these problems here. And I want you to try to understand the difference between these two types of word problems. So our exit ticket asks us to complete the following. When I am given a rate of change, which is our m, our slope, and a starting point, which is our y-intercept, I should write an equation in what form and then do what? When I am given a problem that relates two different objects, I should define what and write an equation in what form. And then I should substitute for either x or y is appropriate, and then what do I solve for? And of course, turn in your work in teams. So for homework tonight, you will have 10 word problems, and that is homework for 11. So remember, we're going to put those cameras on so we can have respectful conversations. Please respond when your name is called at the beginning, the middle, or the end of the period. Submit your completed lesson for class participation. Submit that lesson. Remember, the do now and the exit are done in teams, and the actual algebra problems are done on paper. And that's what you need to submit by tomorrow morning. And also your homework, we'll see that later in the week. Okay, your Unit 4 test is coming up on January 14th and 15th. Today is the last day for alternative assessment, so if you want to do an alternative assessment project for me, you need to see me or write to me today. And if you're working with a partner, you need to tell me who that is. Beginning Wednesday, January 13th, we will have class all day long. You have 7 periods. You'll log into all of your classes. And for the next few weeks in algebra, we're going to have Whiteboard Wednesday. So make sure you have whiteboards. I have 2 people so far who will be picking up whiteboards on Monday afternoon because they don't have them. Make sure your camera is working and that you have the whiteboard and dry erase marker, or else contact me and we'll have you come Monday afternoon to pick that up after school. So let's talk about our do now. We have this Jim Rohn. He's an American entrepreneur, and he said, if you don't design your own life plan, chances are you'll fall into someone else's plan, and guess what they have planned for you? Not much. What does this mean? Okay, and when you formulate a plan, you work your own plan. If you don't have a plan, you'll get tied up in what somebody else wants to do, perhaps. I'm going to start a business. I'm going to work for a gas station. I'm going to get a job at a hospital. And you're going to end up with their plan. Meanwhile, your own dream will just go by the wayside, perhaps. So I want you to respond to this quote and tell me what you think it means in your teams. So here's our exit ticket. So let's move forward with our actual lesson for today. Now, I said there are 4 types of word problems, and type 1 are the slope-intercept problems. And we're going to use these when we are given a rate of change and a starting point. So we're going to use when given a rate of change, and that rate of change, that's our M, our slope, and a starting point. Which is our B, our y-intercept. And remember, these are slope-intercept problems. We're going to be looking to do our work in slope-intercept form, y equals mx plus b. Remember that plus b means plus or minus. Okay, don't get hung up on always looking for addition. It could be subtraction. If the y-intercept is below the x-axis, it will be negative. So we're looking for a rate of change, which will be our M, and a starting point. So let's see what the kind of rhythm of these problems is. And you'll start to, as you work with these, you'll start to recognize kind of a rhythm and the way they kind of flow as they reveal themselves on the paper. So in the first one, we have Evan, who's going to the country fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. If his parents gave him $20, write and solve a linear equation to find out how many rides he can go on. So we're looking for our rate of change, our M, and we're looking for our y-intercept, our B. And the rate of change, well, it says cost per ride. When you see this word per, you know we're talking about a rate of change. So the rate of change is 50 cents, and we'll represent that with 0.50. Talking about money, we'll use 2 decimal places. As we talk more about significant digits, maybe in another part of the course, or maybe you've had it with another teacher, you'll understand the importance of having the right number of decimal points. Now we're looking for that starting point, okay? And I see here that admission to the fair is $5. So that's going to be our starting point, 5.00. We don't need the dollar sign, but we do need to show that this is money. So what is my equation? Remember, there's 2 parts to this. First part says to write the equation, and the second part says to solve the equation. So we're told that these are slope-intercept. We're looking for a y equals mx plus b type of equation. We know that m is our 50 cents and b is our $5. So when we write our equation, we're going to write it y equals 0.50x plus $5. Now, we've wrote the equation. This is part 1 of our answer. Now, for part 2, we have to solve the linear equation. Well, what's missing? We see that the parents of Evan's parents gave him $20. So that's going to be our y equals. So we're going to have $20 equals 0.50x plus $5. And all we need to do is solve it. So let's subtract 5 from each side of the equation. And we have 15 equals 0.50x. And then we'll divide both sides of the equation by 0.5. And x equals 15 divided by 0.5 is 30. So let's step back from the problem for a minute, okay? It's always a good idea to do this. So what did they ask us? We're asked to find out how many rides he can go on. So he had to use up, let's think about this. He's got $20. Okay, there's his $20. He had to spend $5 for admission to the fair. So that left him with $15. Okay, now he's got $15 left. Now, if each ride is half a dollar, 15 divided by half a dollar is 30. He can go on 30 rides. The question asks, how many rides can he go on? So the answer is Evan can go on 30 rides. So this is the slope intercept type of problem. You're going to see this rate of change, something that changes steadily, a rate, okay? It's not going to jump, be 50 cents at one point and 75 cents at another point. A slope intercept problem will have a constant rate of change, okay? And you'll see a starting point. In this case, the starting point was the $5, and the rate of change was 50 cents. So let's look at, and always, 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 I don't want to forget, define your variables, okay? Super important to define your variables. Okay, so now Sally, we have the story of Sally, and while visiting Crimson Lake, Sally decided to go kayaking. The rangers charge $8.50 per hour. Look what I see, per. So that is my rate of change. My M is $8.50. Okay, $8.50 per hour in addition to a $25 deposit. Okay, I've got that initial starting point. My B is $25. If she rented the kayak from 11:30 until 2:30, write and solve, so we have two things to do, write and solve a linear equation to find the total cost to rent the kayak. So we know she has to pony up $25 to get just to as a deposit. Then she has to pay $8.50 an hour. Now I know a lot of you will say, well, Mrs. Gold, I'm just going to add 25 plus 850 plus 850 plus 850, and I'm going to give you the answer. That's great, but this is algebra, so we need to learn to do it this way. You need to show it to me this way. So let me show you how that's done. So we've defined our variables, and we're going to write the linear equation in slope-intercept form. Y equals 8.50x plus $25. Okay, now we have to solve it. Now, our x is going to be substituted for how long we rented the kayak. From 11:30 to 2:30 is 3 hours. So when we solve this, it will be y equals 8 point, let me just write this up a little bit. I want to have room to solve it. Okay, y equals 8.50. There's our 3 hours. That's our slope actually. Because 3 hours is the amount of time that they're renting it for. And remember, it's steady. It's not 8:50 the first hour and then, prime time, 10:50 the second hour. No, steady rate, 8:50 per hour. So that's 3 hours plus that $25. So let's go ahead and solve this. So this is very simple. We don't even have to really use algebra. It's just an evaluation. 850 times 3 plus 25 equals $50.50. And $50.50 is how much it's going to cost her altogether. Now, if we go to Desmos, we can look at some of these problems. Here's our first one. Y equals 0.50x plus $5. This is going to the fair. Let me make this graph a little bit bigger so it makes sense to you. Okay, and this is right here we have this is the $5 that Evan had paid for admission, okay? And the most he can go on is 30 rides. So when we see him go on 30 rides, he's out of money. Okay, so even though these graphs, this is the point I want to make, these graphs go on negative and positive. They go on to infinity. Infinity is often not very appropriate, um, because what happens is these graphs represent, and these problems often represent things that should not be negative, for example, or do not have an infinite amount of money. So you're not going to have a partial person, or you're not going to have a negative amount of money for most of these kinds of problems. So we're mostly, for the most part, with a lot of these, we're really only concerned with the first quadrant and really only concerned with a specific part of the first quadrant that fits the parameters of the problem. The second graph, here is our blue graph, okay? And this is our starting point, 25, right here. And for that one, we had each hour they rent the kayak. So let me kind of explode in on the $30. So here, where we have an x value of 3, we have a y value. Let me just make sure. Check my axis. We tell you when the numbers get big, your x and y axis can get really lost. Okay, so when we have 3, I'm going to add actually a point. No, I can't do that. So using my iPad separate from my computer. So let's find where we have a point of 3. We see that we've spent $50.50. It's kind of hard to show this. Get up there in just a second. There it is. Try it again. We get exactly at 3. There it is. $3 exactly, and we've spent $50.50. There it is. So let's go back to these problems. We'll do another one. This is the story of Alex. Alex bought a new truck for $42,935. According to the dealer, the truck will depreciate approximately $4,200 per year. Write and solve a linear equation to find how many years until the car is worth $5,135. First of all, students, you need to understand that a car is one of the worst investments you'll ever make. You're not going to make money on it. It's not an investment. It's something you need to get around. Cars depreciate in value tremendously, even a new car. As soon as you drive it off the lot, it depreciates. That's why sometimes a slightly used car can often be a very good value. Now, we are talking about depreciation here. Depreciation is subtraction, okay? So this depreciation of $4,200 per year is a negative slope. So that is, our M is going to be negative 4,200. Now, our starting point is the cost of the truck when it's new. So our B equals 42,935. And what are we being asked to do? We want to find a linear equation to find out how many years, okay? So we're not being asked about money. We're being asked about how many years until the truck is worth this amount of money, $5,135. Slope-intercept form, y equals mx plus b. So y equals, our m is negative 4,200x plus 42,935. Okay, let's solve this. So remember, these are two parts. We're asked to write, and then we're asked to solve. So we want to know about when the truck is worth $5,135. So that's going to be our y. So $5,135 equals negative 4,200x plus $42,935. Okay, that's what we need to solve. And we need to find x. Okay, this is what we're looking for. because that's going to represent the number of years, because the truck depreciates $4,200 each year, which is why this number is negative. So first thing I want to do is subtract 42,935 from each side of this equation. Whatever we do to one side, we do to the other. And that cancels that. And the left side of the equation, we have negative 37,800 equals negative 4,200x. Now we divide both sides of the equation by negative 4,200. And remember, a negative divided by a negative is a positive. So x will equal, and if you take your calculator and you divide negative 37,800 by negative 4,200, you will get 9. Now let's review. What did they ask us? How many years? So in 9 years, the truck will be worth $5,135. So now we're at number 4. I saw this deal. There's been snow on the ground. Everybody's getting their car washed. And I've seen deals like this at car washes in the last week or so. Algebra is everywhere. So it says if you buy a car wash at the gas station for $6, the cost per gallon is $2.35. So they're giving you kind of a discount for getting your car washed. They'll give you a discount on your gas. If you have $40, write and solve a linear equation to find the number of gallons of gas you can afford. So, what's our rate of change? Well, we see this per gallon, $2.35. So that's 2.35. That was pretty easy to pick out. But what's our starting point? Okay, is it the $6 for the car wash, or is it the $40 we started with? It's the $6 for the car wash, because we're getting this rate of $2.35 per gallon because we bought the car wash. So the y-intercept is our $6. So now we're going to write an equation. That's the first thing we do, and then we'll solve the equation. So the equation we're going to write in slope-intercept form is y equals 2.35x plus 6. Now we need to solve that equation. And we're going to solve that equation by making y equals 40, because 40 will equal the $6 for the car wash plus $2.35 times a certain number of gallons. And that's what they're asking. Find the number of gallons. So let's go ahead and insert our $40 for y. 40 equals 2.35x plus 6. So we subtract 6 from both sides, and we have 34 equals 2.35x. And we divide both sides by 2.35, and 34 divided by 2.35, that of 5, is 14, I'll round off, 14.47 gallons. And remember, they asked us about how many gallons. So a little under 14 and a half gallons, 14.47 gallons. So those are the slope-intercept type of problems. The next type of problems are the standard form problems. And we're going to use the standard form problems when the problem relates two different objects to each other. So we'll use those when the problem, this is really important, relates. These are relations. Relates two different objects. Now, standard form of an equation, let's remind ourselves. AX plus BY equals C. So in these problems, we're going to define our X and our Y. So we'll start out with Sam, who ordered 2 hamburgers and 3 hot dogs from the concession stand at the baseball game. His bill, or the amount he paid, came to $19.05. If hamburgers cost $5.25 each, write and solve, so we have 2 chores ahead of us, a linear equation to find the cost of each hot dog. We're finding the cost of 1 hot dog, okay, of each hot dog. Well, let's make X our hamburgers, and let's make Y our hot dogs. So my standard form of an equation, remember AX plus BY equals C, it says here he ordered 2 hamburgers and 3 hot dogs. So that would be 2X plus 3Y equals what his bill came to, $19.05. Now, that's the first part. We did the first thing. We wrote the equation. We did that. Now we need to solve the equation. And we're going to solve it by inserting this given information about the hamburgers, which is hamburgers cost $5.25 each. So that's going to be our new X. So we're going to have 2 times $5.25 plus 3y equals $19.05. So 2 times 525 is 10.5, $10.50, plus 3y equals 19.05. Now we'll subtract $10.50 from each side, because remember, eventually what we're looking to do is isolate y. So this would cancel. 3y equals $8.55. So I subtracted 1050 from 1905. Then I'm going to divide both sides of the equation by 3, and y will equal $2.85. And that is the cost of each hot dog. And hot dogs are always a little bit cheaper than hamburgers, at least in my experience, that has been. So now let's look at the tickets at a high school play. Tickets at a high school play cost $4 in advance and $5 at the door. So right away we can see these are the 2 objects, or the 2 items that we are relating in this problem. So we can go ahead right now, even without reading the rest of the problem, we can go ahead and define these variables. We'll make X our advance tickets, and we'll make Y the tickets at the door tickets. So total ticket sales for the evening production were $440. If no tickets were sold in advance, so everything is at the door, write and solve, so we have 2 tasks, a linear equation to find out how many were sold at the door. So remember, standard form of an equation, AX plus BY equals C. So $4 in advance, $5 at the door. That would be 4x, $4 in advance, plus $5 at the door, 5y, equals $440. Now it says if no tickets were sold in advance. Well, that means we're going to substitute x for 0 and solve for y. So 4 times 0 plus 5y equals 440. So 4 times 0 is 0. 5y equals 440. We divide both sides by 5, and we find that our y equals 88. So 88 tickets were sold at the door, and I'm sure they were very nervous when they did not sell any advance tickets. And they just said, oh, I hope a lot of people come and buy them at the door. And it looks like they sold 88 tickets. So you could figure out, well, yeah, if they sold 15 at the door in advance, how many would that be at the door? Or you could look at the graph, which would be this one right here. I'll turn off the other one. It's hard to see this graph because, let's see, let me turn it on again. There it is. Okay, any combination of points along that line that are divisible by 4 and 5 would give you an amount of tickets that they could, any combination of tickets that they could have for advance tickets or tickets at the door that would result in $440 being sold. So any combination along here would work. So let's get back to our problem. Karen's piggy bank has all dimes and quarters. The total value of the money in her piggy bank is $11.40. I can already tell we're relating dimes and quarters. Let's finish reading. If Karen has 36 quarters, write and solve a linear equation to find the number of dimes she has. So let's make X equal our dimes and Y is going to equal our quarters. So our standard form equation, dimes are represented 0.10 X plus quarters 0.25 Y equals, and she has $11.40, 11.40. So that's our standard form of the equation. Now let's solve the equation. If she has 36 quarters, so we're going to substitute the quarters for Y, so and solve for X. 0.10X plus 0.25 times 36 equals $11.40. So 0.25 times 36 is 9, so that would be 0.10x plus 9 equals $11.40. We'll subtract 9 from both sides. That will give us 0.10x, be very careful with these decimal points, equals $2.40. And we'll divide both sides by 0.10, which would make X equal 24. That's 24 dimes Karen has in her piggy bank. And our final problem for today, because we'll start the third type on Monday, the Oakville High School marching band. This is such a common problem, and it's a real world problem. You've probably done this, sold gift wrap or sold something for a club or for a band. So they sold gift wrap to earn money for the trip. Good for them, we're glad. But let's get to the information we need for the problem. Solid color gift wrap sells for $3.50 a roll, and printed gift wrap sells for $5 a roll. Well, that's those two items that we're going to relate. We've got solid and we've got printed. The band needs to earn $2,500 for an upcoming competition. If they sell 325 rolls of printed paper, write and solve a linear equation to find the number of rolls of solid paper they must sell. So define our variables first. X will be the solid paper, which is looks like it's a little cheaper. Y will be the printed paper, which is more expensive. So the solid paper is $3.50 a roll. So 3.50x plus the printed paper is $5 a roll, so 5.00y equals, and how much money do they need to make? $2,500. So that's step one. We've written the equation. Now we need to solve the equation. I think I may need a little more room here. There we go. So let's change our color and solve the equation. We're solving for y because we're solving for x because it says if they sold 325 rolls of printed paper. So that's our y. We're going to solve for x. We don't know what x is. So 3.50x equals 5.00. Our y they gave to us in the problem, 325 rolls. So 3.50x plus 5.00y equals $2,500 because that's the amount they need to make this trip. So the first thing I will do is I'll multiply 5 times 325. 3.50x plus, and 5 times 3.25 is 1,625 equals 2,500. Now we're solving for x, so first we want to get rid of this 1625 by subtracting it, and whatever we do to one side of the equation we'll do to the other. So here this will cancel, and we will have 3.50x equals 875. Now we'll divide both sides by 3.50. And yes, you can let your calculator help you. And x will equal 250. So we're dividing 875 by 3.50, which will give us 250. 250 what? Rolls. What kind of paper? Rolls of solid paper. And that's our final answer. So I just want to remind you, it's always good to graph these with Desmos along the way. We may not be able to use our calculators this year, but you certainly have that wonderful resource available to you. So let's go back to our exit ticket and let's fill in the information to really drive this home. So when I'm given a rate of change, which is our m, our slope, and a starting point, b, which is our y-intercept, I should write an equation in slope-intercept form and then solve for y. And those problems we did, you're solving for y. Now, when I am given a problem that relates to different objects, I should define the x and y values. Define what they are. Is it, they're going to be a number. Is that the price of advance tickets, or is that the price of tickets at the door, or is that the price of solid paper, printed paper, vanilla ice cream versus chocolate ice cream? I mean, you have to look at the problem and see what you're dealing with. Then you write an equation in standard form. And then I should substitute for either x or y as appropriate. Sometimes you're going to solve for x, sometimes you'll solve for y. And so I'm going to solve for either x or y as appropriate, and then solve, you see your substitute, then solve for the remaining variable. And that's generally how those problems work. So you've got 10 to try for homework. Take your time, but give it a shot. wrong answers are better than no answers. You guys have been working very hard. Let's take it on home. Let's really do well with this. What we've done today, this is sort of like what the alternative assessment is going to be like. I'm going to give you a couple of these type of problems, have you work on them, check your answers with me, and when we've got your answers correct, I want you to make a nice little mini Tiger Talk video that shows these problems. You can make a PowerPoint, or you could act them out, and no more than 7 minutes long. So keep on practicing because you know the drill. As long as you practice, you'll be great.